Okay, now I'm going to continue my explanation of the Candy Crate worksheet using not just force diagrams, but force graphs. So in this first section, I will call this time frame 1. If we go right to the net force, the net force is 0. So if I go for 3 seconds and the net force is 0, that also means I have an acceleration of 0. And I do not have a change in velocity. So that means that I won't have any slope here. There will be no change in velocity. And that also means that I will go nowhere. So I'll have no change in whatever. So I have my acceleration equals 0, my net force equals 0, and that's situation number 1. Situation number 2 here is a tug. Sure. So for 3 seconds I will show a little bit of a tug, and so the force of the pull is that, and the friction is the opposite, is that. So once again, the net force will still be 0, and so it doesn't accelerate. It doesn't have a change in velocity, and it doesn't have a change in location. So the third scenario here, it is now going to accelerate. And so the way you accelerate is you have the net force greater than the friction. So if the friction is still down here, this is the force of friction, and this is the force of the pull. Now you're saying that the net force would be right there in the middle. So now we do have a net force that does not equal 0. So this one will accelerate, and the acceleration will be proportional to the net force. So A will be proportional to the net force, and it's not equal to 0. So that means that we'll increase our velocity something like that. And our distance, since we're accelerating, will be a little bit of a curve like that. So we do have a change in position now, and we do have a change in velocity. And then for the last section, section number 4, now we are going to have a constant velocity again. So we're actually going to be pulling this until the force of our pull once again equals our force of friction. So this is the force of the pull, and this is the force of friction. And so since they equal each other, then now it will be your net force, once again, will be equal to 0. And so your acceleration drops back down to 0. And then what that means is that your velocity will no longer change. And so your delta V is non-existent. Your delta V was non-existent there. Your delta X was non-existent there. But now, since we are still going velocity, your velocity doesn't equal 0. You're just not changing. Now you're going to keep whatever slope that you had before. You're going to keep that same slope. And so that's what we call constant velocity. So we have all 4 scenarios. We have constant velocity, not moving, no force. We have constant velocity with a force, but not enough to budge us. We have constant acceleration, where our force is greater than our force of friction, and so we get an acceleration. Our velocity changes, our position begins to get farther and farther, and then we equal out our forces so that our acceleration actually is 0, which simply means that we stay at the same velocity as before. And the straight line here says that we stay at the same velocity as before. And that is the force diagrams and the XVA graphs for the Candy Crate.